couple of examples of how these concepts are used together. In the following example, the Duo SSO and multi-factor authentication services provide user authentication for 3 different cloud services: Cisco WebEx, Cisco Meraki Cloud, and Cisco Umbrella. SSO is done using the SAML protocol. Cisco WebEx is a cloud SaaS collaboration service that is extremely popular among enterprises and businesses alike. Cisco Meraki is a series of solutions for businesses of all sizes that provide networking, wired and wireless, and security products that are managed in the cloud. And Cisco Umbrella, formerly known as OpenDNS, is a cloud-based solution that protects thousands of organizations and users around the world. Cisco Umbrella blocks malicious destinations before a connection is ever established. Another example of how Duo provides user multi-factor authentication and SSO to different services, including VPN users, Microsoft Azure applications, remote desktop protocol implementations, secure shell, API app authentication, and other implementations. The Duo Cloud Platform not only provides multi-factor authentication and SSO services, but also device visibility, user policy, and device policy checks. Is network visibility. The truth is, you can't secure it if you don't know that it exists on your network. Visibility is the first step in controlling and securing your environment. There are multiple techniques that can be utilized on your network to obtain visibility necessary to maintain control during an outbreak or compromise. If you do not have complete visibility, you will have blind spots on your network. The blind spots are where the bad guys hide. This includes critical systems as well as unnecessary services. Any of these can be compromised. Some of the most common technologies that can be utilized to obtain network visibility include Netflow, IPFix, Cisco StealthWatch, intrusion detection and prevention systems, as well as advanced malware protection. Many organizations fail to use one of the strongest tools that can help protect against today's security threats, the network itself. For example, Cisco Catalyst switches, data center switches, ASR routers, integrated services routers, next-gen firewalls, next-gen intrusion prevention systems, Netflow generation appliances such as StealthWatch, flow sensors, and advanced malware protection all work in conjunction with the Cisco application-centric infrastructure to protect before, during, and after the attack. The network can be used in security in 2 different fundamental ways. The network as a sensor, where Netflow allows you to use the network as a sensor, giving you deep and broad visibility into unknown and unusual traffic patterns, in addition to compromised devices. And the network as an enforcer, where you can use Cisco TrustSec to contain attacks by enforcing segmentation and user access control, even when bad actors are involved. Originally created by Cisco, it provides comprehensive visibility into network traffic when it traverses a network-supported device. The original use for Netflow was for billing and accounting purposes. For instance, during the dark ages of dial-up internet access, it was used to account for bandwidth and dial-up utilization. With the evolution of Netflow, it now brings along the capability to be utilized as a tool for network visibility and security. Let's take a quick look at how Netflow works. Here, you have device A and device B. In between, you have a switch A and switch B, as well as router A. When a packet traverses from device A to B, it touches each of these devices. If these devices are capable of Netflow, they will record a flow record for this transaction, one out the inbound and one for the return traffic. It's like a phone call record. A flow is considered a unidirectional series of packets between a given source and a destination. With each flow, the source and destination IP address is recorded, as well as the source and destination ports and protocol. This is referred to as the 5-tuple. The 5-tuple is depicted here in the graphic. There are many versions of Netflow used in the industry today. However, not all of them are useful for security visibility. The Internet Flow Information Export, or IPFIX, is a Netflow standard led by the IETF. The purpose of IPFIX was to create a common universal standard of export for flow information from routers, switches, and other infrastructure devices. IPFIX is documented in RFC 7011 through 7015, as well as RFC 5103. Cisco Netflow version 9 is what IPFIX was based on. Note that IPFIX records are exported via UDP messages. Reduces costs and improves capacity planning and security detection beyond other flow-based technologies available today. Flexible Netflow supports IPv6 and Network-Based Application Recognition, or NBAR 2, for IPv6 starting in Cisco iOS software version 15.2. It also supports IPv6 transition technologies. Flexible Netflow can detect the following tunneling technologies that give full IPv6 connectivity for IPv6 capable hosts that are on the IPv4 internet but have no direct native connection to the IPv6 network. It supports Teredo, Intrasite Automatic Tunnel Addressing Protocol, ISATAP 624 6RD. Flexible Netflow tracks different applications simultaneously. For instance, security monitoring, traffic analysis, and billing can be tracked separately, and the information customized per application. Flexible Netflow allows the network administrator or security professional to create multiple flow caches or information databases to track. Conventionally, Netflow has a single cache, and all applications use the same cache information. With Flexible Netflow, it supports the collection of specific security information in one flow cache and traffic analysis in another. Subsequently, each Netflow cache serves a different purpose. For instance, multicast and security information can be tracked separately, and the results sent to two different collectors. The figure here shows the Flexible Netflow model and how three different monitors are used. Monitor 1 exports Flexible Netflow data to Exporter 1. Monitor 2 exports Flexible Netflow data to Exporter 2. And Monitor 3 exports Flexible Netflow data to Exporter 1 and Exporter 3. The following are the Flexible Netflow components: records, flow monitors, flow exporters, and flow samplers. In Flexible Netflow, the administrator can specify what to track, resulting in fewer flows. This helps to scale in busy networks and use fewer resources that are already taxed by other features and services. Records are a combination of key and non-key fields. In Flexible Netflow, records are appointed to flow monitors to define the cache that is used for store flowing data. Records are a combination of key and non-key fields. In Flexible Netflow, records are appointed to flow monitors to define the cache that is used for storing flow data. There are 7 default attributes in the IP packet identity or key fields for a flow and for a device to determine whether the packet information is unique or similar to other packets sent over the network. Fields such as TCP flags, subnet masks, packets, and number of bytes are non-key fields. However, they are often collected and exported in Netflow or IPFIX. There are several Flexible Netflow key fields in each packet that is forwarded within a Netflow-enabled device. The device looks for a set of IP packet attributes for the flow and determines whether the packet information is unique or similar to other packets. In flexible NetFlow, key fields are configurable, which enables the administrator to conduct a more granular traffic analysis. You can enable NetFlow on network devices at all layers of the network to record and analyze all network traffic and identify threats such as malware that could be spreading laterally through the internal network. In other words, malware that spreads between adjacent hosts in the network. Note that, as a best practice, NetFlow should be enabled as close to the access layer as possible. This means the user access layer, data center access layer, and VPN terminal points. Another best practice is that all NetFlow records belonging to a flow should be sent to the same collector. You can also deploy NetFlow in the internet edge to see what traffic is knocking on your door and what is leaving your network. The Cisco ASR 1000 series routers provide multi-gigabit performance to meet the requirements for internet gateway functions for medium and large organizations. The architecture of the Cisco ASRs include the Cisco Quantum Flow processor that provides a lot of high-performance features such as application layer gateways, all layer 4 and layer 7 zone-based firewall session processing, high-speed NAT and firewall translation logging, as well as Netflow event logging. Netflow event logging, otherwise known as NEL, uses Netflow version 9 templates to log binary syslog to NEL collectors, allowing not only the use of NAT at multi-gigabit rates, but also the ability to record NAT and firewall session creation and tear down records at very high speeds. So let's jump in. First, we log into our switch and enter the enable command. Then we enter configuration mode. The first thing we're going to do is create a flow record. We can add an optional description here as well. Next, we need to configure the key fields for the flow using the match command and the non-key fields using the collect command. I'll speed this video up as there are a number of commands to enter here. Once we finish up adding these commands to the flow record configuration, we will move on to configure the flow exporter with the flow exporter command. In this, we will define the destination of our NetFlow export. From here, we move on to configure the flow monitor. Here we define the flow record and exporter we created, and we also set a cache timeout. Finally, we will apply the flow monitor to an interface. Network segmentation is the process of logically grouping network assets, resources, and applications. Segmentation provides the flexibility to implement a variety of services, authentication requirements, and security controls. Working from the inside out, network segments include the following types: an enclave network, which is a segment of the internal network that requires a higher degree of protection. Internal accessibility is further restricted through the use of firewalls, VPNs, VLANs, and network access control devices. Trusted network, wired or wireless, is the internal network that is accessible to authorized users. External accessibility is restricted through the use of firewalls, VPNs, and IDS/IPS devices. Internal accessibility may be restricted through the use of VLANs and NAC devices. A semi-trusted network, or perimeter network, also considered a DMZ, or demilitarized zone, is a network that is designed to be internet accessible. Hosts such as web servers and email gateways are generally located in the DMZ. Internal and external accessibility is restricted through the use of firewalls, VPNs, and IDS/IPS devices. Guest networks, either wired or wireless, are networks that are specifically designed for use by visitors to connect to the internet. There's no access from the guest network to the internal trusted network. And untrusted network is a network outside your security controls. The internet is considered an untrusted network. Another dilemma is the machine-to-machine communication between different systems and applications. How do you also segment and protect that in an effective manner? In today's virtualized and containerized environments, traffic between applications may never leave a physical device or server. This is illustrated in the diagram below. This is why microsegmentation is so popular nowadays. A solution of the past is to include virtual firewalls between VMs, as shown in the diagram below. Machine-to-machine or application-to-application communication also needs to be segmented within an organization. For instance, let's take a look at this figure. Does your Active Directory servers need to communicate to network time protocol servers? What is their relationship and data interaction? NTP implementations send and receive timestamps using UDP port 123. However, NTP servers can also use broadcasting or multicasting, where clients passively listen to time updates after an initial round-trip calibrating exchange. Which of the two need to be allowed or protected? Of course, this is a simple example, and in this case, UDP port 123 can be used. However, what if an attacker can tunnel traffic over NTP and exfiltrate information from the organization? All these questions need to be answered when you are creating your segmentation strategy. Furthermore, do you know what applications are running in your environment? What applications are talking to the cloud? Which are hosted in the cloud? How do you do application enumeration and mapping? However, one of the most elegant solutions of microsegmentations is the one provided by Cisco Application-Centric Infrastructure, or ACI. Or COA is a feature that allows a radius server to adjust an active client session. For instance, ICE can issue a COA radius attribute to an access device to force the session to be re-authenticated. An example is the use of COA when the Threat-Centric Network Access Control, or TACACS, detects a vulnerability. The TACACS is a feature that enables ICE to collect threat and vulnerability data from many third-party threat and vulnerability scanners and software. The purpose of this feature is to allow ICE to have a threat and risk view into the host it is controlling access rights for. Note that the TACACS feature enables you to have visibility into any vulnerable hosts on the network and to take dynamic network quarantine actions when required. ICE can create authorization policies based on vulnerability attributes, such as the Common Vulnerability Scoring System, or CVSS scores, which are received from your third-party threat and vulnerability assessment software. Threat severity levels and vulnerability assessment results can be used to dynamically control the access level of an endpoint or a user. When a vulnerability event is received for an endpoint, Cisco ICE can then automatically trigger a change of authority for that endpoint, as demonstrated in the diagram below. Identify a local area network is to say that all the devices in the same LAN have a common layer 3 IP network address, and that they also are all located in the same layer 2 broadcast domain. A virtual LAN, or VLAN, is another name for a layer 2 broadcast domain. VLANs are controlled by the switch. The switch also controls which ports are associated with the VLANs. We often take for granted layer 2 in the network because it just works. Address Resolution Protocol, or ARP, and layer 2 forwarding on Ethernet are all proven technologies that work very well. The CCNP security and CCIE security certifications are built with the presumption that candidates would have some of the fundamentals of routing and switching. With this knowledge, your understanding of the details about VLANs, trunking, and inter-VLAN routing is presumed. However, so that you absolutely understand these fundamental concepts, this lesson will begin with a review. It is important to make sure that the basics are in place so that you can fully understand the discussion about protecting Layer 2 in the last section of this lesson, which covers the really important stuff. That section focuses on just a few Layer 2 related security vulnerabilities and explains exactly how to mitigate threats at Layer 2. If you are currently comfortable with VLANs, trunking, and routing between VLANs, you might want to jump to the next lesson. In a previous lesson, you learned that VLANs can be used to segment your network and are assigned to switch ports, as well as wireless clients to enforce policy. In this lesson, you will also learn about several security challenges when protecting Layer 2 networks, VLAN assignment, and trunking protocols. However, you must understand the basics of how VLANs and trunking operate before you can learn how to secure these features. This section reviews how VLANs and trunking are configured and how they operate. This diagram serves as a reference for the discussion going forward. You might want to screenshot this page or take a moment to make a simple drawing of the topology. You'll want to refer to this illustration often during this discussion. So what is a VLAN? One way to identify a local area network is to say that all devices in the same LAN have a common Layer 3 IP network address, and they also are all located in the same Layer 2 broadcast domain. A virtual LAN, or VLAN, is another name for a Layer 2 broadcast domain. VLANs are configured on the switch. The switch also controls which ports are associated with the VLANs. In the diagram here, the switches are in their default configuration. All ports by default are assigned to VLAN 1, and that means all the devices, including the two users and the router, are all in the same broadcast domain, or VLAN. As you start adding hundreds of users, you might want to separate groups of users into individual subnets and associated individual VLANs. To do this, you assign the switch ports to the VLAN, and then any device that connects to that specific switch port is a member of that VLAN. Hopefully all the devices that connect to the switch ports that are assigned to the given VLAN also have a common IP network address configured so that they can communicate with other devices in the same VLAN. Often, Dynamic Host Configuration Protocol, or DHCP, is used to assign IP addresses from a common subnet range to the devices in a given VLAN. If you want to move the two users in the diagram to a new common VLAN, you create the VLAN on the switches and then assign the individual access ports that connect the users to the network to that new VLAN, as shown in the example here. In the example, interface gigabit Ethernet 2 of switch 1 is configured as an access port and assigned to VLAN 10. Interface gigabit Ethernet 2 of switch 2 is configured as an access port interface and assigned to VLAN 20. You can do a quick verification of the newly created VLANs and associated ports with the show VLAN brief command as demonstrated here.